If you took a look at a world map, it would be easy to think that the Earth has always looked like this and always will. However, this is just how the Earth's surface looks currently, because it is changing all the time. Most of these changes happen in the lithosphere. Earth's lithosphere is divided into many tectonic plates that are different in shapes and sizes, but fit tightly together like a jigsaw puzzle. There are 7 large key plates and several smaller plates, and our lands and oceans lie on top of them. Did you know that all of the continents that we know today once formed a single supercontinent? This supercontinent existed 335 million years ago, and we call it Pangaea. Over millions of years, the tectonic plates which hold the continents moved around, smashing into each other and then pulling apart. This process is called plate tectonics, but is sometimes also known as continental drift. How did the plates manage to move the continents to where they are today? To find out, we'll have to look at what lies under the plates. Within the Earth, there is tremendous heat and pressure, and this drives slow circular movements called convection currents within the mantle layer, which in turn cause the plates to move. Different tectonic plates meet each other at their boundaries, which are known as plate margins. There are 3 types of plate margins depending on what kind of movement occurs between the 2 interacting plates. At a constructive or divergent plate margin, 2 plates move away from each other. This movement forms a gap between plates, which allows magma to seep through and cool to form new geological features such as volcanoes. The Mid-Atlantic Ridge under the Atlantic Ocean is an example of a constructive plate margin. At a destructive or convergent plate margin, 2 plates move towards each other. This can either cause one plate to go under and the other to be pushed up, or 2 plates to smash together and push upwards. This process can form majestic fold mountains and deep trenches, and often create powerful earthquakes. This is how the Himalayas in Nepal, home of Earth's highest mountain, Mount Everest, were formed. At a conservative or transform plate margin, 2 plates slide against each other, either in different directions or in the same direction at different speeds. These parts of the world also experience earthquakes due to the movement of these plates. An example of this is the San Andreas Fault in California. Our Earth is a dynamic and active planet, and its surface is composed of many individual plates that are always on the move due to the convection currents within. The plates are moving far too slowly for us to notice, yet they are responsible for the most devastating tectonic hazards.